How did you do with this first one? Anybody know what this antiderivative is? 3 times what? The natural log of x. Now we're going to go from 1 to infinity for this. So this is saying you're going to go 3 times the natural log of infinity minus what? 3 times the natural log of 1. Now I know what the natural log of 1 is. What's that? 0. But what's the natural log of infinity? It does go to infinity. So this area, as you would expect, goes to infinity. 3 times infinity is infinity. So this is an infinite area. Not very helpful. But look at this one. Look at this one here. We're going to rewrite this as 2x to the negative 2. Now, what's that antiderivative? 2x to the negative 1 over negative 1, going from 2 to infinity. So then, we're going to rewrite this, if you don't mind, negative 2 over x, going from 2 to infinity. So far, so good? Is that okay? This is 1 over x times negative 2. All right, now put in infinity. What's negative 2 over infinity minus a negative 2 over 2? What is negative 2 over infinity? That goes to 0. And what's plus 2 over 2?
1.
Wait a minute. That area from 2 to infinity is 1? Let's look at a picture quick. Not computing. You have 3 over infinity looks something like this. So if we went from 1 to infinity, they're saying that this area, this is for the first one here, that's going to be an infinite area. I can buy that. Now the next one has 2 over x squared. It's still, you know, this shape. But if you start at 2 here and go to infinity, this area is 1. What's the difference between these two? Yeah, this is a little bit tighter. This goes to 0 a little faster. This one goes to 0 a little slower. And for some reason, this one doesn't give you a finite sum, and this one does mathematically. We'll play around with that a little bit more. But that's the idea behind an improper integral. Improper integral doesn't mean its pinky isn't up. It just means that you can't, you're going to either positive infinity or you're going to negative, coming from negative infinity. You go 0 to infinity, or a to infinity, or negative infinity to b, or negative infinity to infinity. And by the way, these do exist. You can find areas from negative infinity to infinity, which is really crazy. And everything else applies. Everything you've done so far still holds. For example, everybody go to this one. This is x e to the negative x. Turn to your neighbor, tell them what technique you're going to use to evaluate that. Make my day. Now turn to another neighbor and tell them what you guys agreed on. And well, Charlie, tell me what you think. Anybody agree with that? Raise your hand if you agree with integration by parts. How many of you disagree? Okay, you're afraid. And you should be, because it is integration by parts. Yes, it is. Because you have two variables multiplied together. There's no u sub that's going to work. Derivative of x is 1, and you're going to have an extra x there. So we're going to do integration by parts, u dv, v du, and we're going to do not only a definite integral, we're going to go to infinity, which makes it an improper integral. Okay, so what do you want u to be, x or e to the negative x? X, and then I'd go e negative x. It's technically e to the negative x dx. What's the derivative of x? dx. So notice when you use integration by parts, wherever the d something is, there'll be a dx, technically. And then this one will be negative e to the negative x. We getting good at those? All right, so now we go crazy x marks the spot, yielding the formula of negative x e to the negative x minus the integral of negative e to the negative x dx. This will be negative x e to the negative x. What's the antiderivative of e to the negative x? Yes, because u is negative x, du is negative dx, and so we got to put that in. And so this is just going to be minus e to the negative x. And we are going from a constant, we could say 2 or 1, but we're going to say a to infinity. Huh? That doesn't sound good. Let's put those in now. We're going to go negative infinity, that looks bad. E to the negative infinity, that looks bad. Minus e to the negative infinity, that's not bad. Minus negative a, e to the negative a, minus e to the negative a.
Why are we doing the first part from a to
This is, we're doing an improper integral from a to infinity. We took this, and now we're going from a to infinity. Top number first, bottom number last. So this is going to be equal to negative infinity over e to the negative infinity minus 1 over e to the infinity minus a negative will be plus a times e to the over e to the a minus 1 over e to the a. What does this do here? What does this thing do? 1 over e to the infinity. I like that. But what's infinity over e to the negative infinity? Maybe? That's right. It is an indeterminate form. So what do we have to do? Try and do L'Hopital's rule. Yeah. That felt good. Hear you upset. No, it doesn't. Limit as, let's go, n approaches infinity of, this was, I'm going to say x approaches infinity. Let's do this one. It's negative x over e to the x. We found that that limit of the top was going to be infinity, and the bottom was infinity, so we have the infinity over infinity indeterminate form. But if you took the limit as x approaches infinity, what's the derivative of x? Negative 1. What's the derivative of e to the x? E to the x. What is negative 1 over e to the infinity? 0. No, not for L'Hopital's. L'Hopital's a separate, separate technique. I'm glad you brought that up. So this actually goes to 0 as well. So my final answer for my area is going to be a minus 1 over e to the a. And a could have been 7. It could have been 1. Couldn't be, it could have been 1. But that's your final area. A minus 1 over e to the a. What do you think? So it's just a little twist on what we've been doing. You might have to use L'Hopital's in there. Let's do 5a, because I know if we do 5a, you'll be happy that we did. Okay. I'm going to integrate dx over x squared plus a squared. Tell me what pops out at you as an antiderivative. What pops out? What is it? Arctangent. Yep. A is just a, and u is x. Du is dx. So this thing is equal to the 1 over a arc tangent of x over a going from a to pi. Pi. Infinity. Pinfinity. So then a to infinity. So as you're moving along here, you get 1 over a arc tangent of infinity over a minus 1 over a arc tangent of a over a. By the way, what's a over a? 1. What is the arctangent of infinity? Now I'm going to draw you a picture, and you're going to remember this from before. Here is arctangent. What is the limit as you go to infinity? What is this? What is this? No, not 1. It's pi over 2. And this is negative pi over 2. So for arctangent, y equal arctangent, that as x goes to infinity, that y value is going to finish at pi over 2. And the arctangent of 1 was just pi over what? 4. So 1 over a times pi over 2 minus 1 over a times pi over 4 is going to be 1 over a times, what's pi over 2 minus pi over 4? What's that? Yeah, it's just pi over 4. So you can say it's pi over 4a. It's your area of that.
Why is that? Because
Huh? What?
pi
Huh?
over 2, like how did you get arctangent pi over arctangent of
Infinity?